Hi and welcome back to Mrs. Riley's Maths videos. This is a video about linear sequences. It's a junior cert video, so it'll use junior cert terminology, which is different to the terminology we use in leaving cert, but hopefully it will be helpful if you're just coming across this idea of linear sequences. So let me give you an example of some linear sequences. Here's one here: 5, 8, 11, 14, 17. 20, 18, 16, 14, 12, minus 6, minus 2, plus 2, plus 6, plus 10. Okay, so there's three linear sequences. Hopefully you can spot that each sequence there's something in common between the terms. So hopefully you can look at that and you can say, well, yes, here what's happening is, and I'll write it in pen here, we're going up by 3 each time, aren't we? We're going up by 3. Okay, here what are we doing? We're going down by 2. We're subtracting 2 to get to the next term. And here, what are we doing? Well, remember, how do we find it out? We talked about it the other day. You subtract or find the gap. So if I have minus 2 minus 6, that's plus 4. So we're increasing by plus 4. Probably easier actually to see it over here. To get from 6 to 10, we're adding 4. Is that the same as 2 to 6? Yes, it is. Is that the same as here? To add 4, add 4. Okay, don't know why I had 2 there. Okay, now just for reference, these are often called differences. And what we say, certainly at leaving cert level, is that a linear sequence has a common difference. We're adding on or subtracting, so adding or subtracting the same number each time. That's what a linear sequence is, the same number each time. How do we know if something's a linear sequence or not? Well, when we're given the sequence 7, 12, 17, 22, to show that something's a linear sequence, so is it a linear sequence? To show that it's a linear sequence, we find the gap or the difference. Here the gap is 12 minus 7, which is 5, adding on 5. Here the gap is 17 minus 12, which is 5. So again, adding on 5, and we can see here, yeah, add on 5. So here the difference is add on 5, and that shows that as it's the same again and again and again, it's a constant, it doesn't change, it's a linear sequence. Look at this one here: 10, 14, 20, 28. What's happening here? Let's see, the gap here will be 14 minus 10, which is 4. The gap in the next one is 20 minus 14, which is 6. The next one is 28 minus 20, which is 8. Actually, this is not a linear sequence because the difference keeps changing. Now, what we'll find out later on is that hopefully you've seen here there's actually a pattern or a sequence here in the differences 4, 6, 8. What we'll find out is that where there's a sequence in the differences, that's another type of sequence called a quadratic sequence, which of course quadratic is a word you've heard before. Anyway, so that's the first thing. That's what a linear sequence is, where there's a difference that's the same each time. Now sometimes to describe what's happening, they come up with a rule to describe or to calculate a sequence. Now we'll look the next day about how do you find that rule, but for now let's just see what the rule might look like. So they might tell you, and let me just check they use the terminology. So the way the rule is they talk about Tn equals something. Now this Tn here is called the nth term. Nth term. Okay? It can also be called the general term of a sequence. I like to call it the any term. So in other words, if you want to find any term in a sequence, you can do it using the nth term. So some examples of what a rule might look like, it might be that Tn is equal to 4n plus 3. Tn is equal to 4n plus 3. What does that mean? It means that I can find the first term, the nth term. The first term is the term where n equals 1. The first term has n equals 1. So T1 is equal to 4 by 1 plus 3, which is 4 plus 3, which is 7. The second term, let's say it's the first, this is the second, the nth term, the second term n equals 2. So T2 is equal to 4 by 2 plus 3, which is 8 plus 3, which is 11. The third term, what do you reckon you're going to do for that? Very good, it's the third term, so n is equal to 3, so T3 is equal to 4 by 3 plus 3, which is 12 plus 3, which is 15. So I found the first three terms of my sequence, 7, 11, 15. Say I wanted to find the 100th term. So the 100th term of this sequence, that would mean n is 100. So T100, you notice these are little what are they called? Subscript numbers, okay? So these are little subscript numbers. They go, did you see the way n equals 100? It meant it means I put 100 where n is. So T100 would be 4 by 100 plus 3 is equal to 403. So once we have the rule of a sequence, we can find any term we like in that sequence. Okay, let's say Tn is equal to 16 minus 3n. Okay, so T1, the first term, will be 16 minus 3 by 1, which is 16 minus 3, which is 13. T2 will be 16 minus 3 by 2, which is 16 minus 6, which is 7. T3 will be 16 minus 3 by 3, which is 16 minus 9, which is, 16 minus 3 is 13, 16 minus 6 is 10, 16 minus 9 is 7. And say we wanted to find T600, it would be 16 minus 3 by 600, which would be 16 minus 1800, which would be minus 1794. Okay, hopefully that's beginning to make more sense for you.